Hello and welcome everyone to a new series on downhole microseismic data processing. The material that we will cover is mainly coming from my book, and more specifically we will review content from chapter 3, which is about microseismic data processing. We will review the processing workflow for downhole microseismic data, then we will dive a bit deeper into these processes. The last of which will be hypocenter location, which is a fundamental outcome from the processing of microseismic data. We start with the available information. Typically, we need information related to the geometry, waveforms, and subsurface model. In geometry, we need wellhead coordinates for monitoring and treatment wells, the corresponding deviation surveys, spatial positions of receivers and calibration charts, and any other related information. The waveforms contain continuous recordings that can include background noise monitoring periods as well as the calibration charts. The subsurface model information typically is obtained from well logs, surface seismic data, or any prior knowledge of local geology from experience of doing similar projects in the area or knowing about these. There are two commonly known ways of processing microseismic data. One uses the travel times of PNS wave arrivals, whereas in waveform-based methods such as stacking or migration, very little to none arrival picking effort is involved. Here we will focus on the workflow that uses methods based on travel time picking. After we load the available data and perform necessary QC, we can see two different tasks. One involves waveform processing and the other model building. In waveform processing, we process monitoring data, and we also process calibration charts to retrieve useful information. The waveforms from calibration charts undergo DC removal, filtering, PNS arrival picking. And then we use these to find receiver orientations, which help to rotate the data into geographic coordinates. Since we know the true spatial location of calibration charts, we can use this information and the peak times to calibrate the velocity model. The monitoring data comprises of waves recorded for several hours or days continuously. Most of it includes background noise, and we are only interested in extracting useful information from these waveforms that is easy to understand and which we can correlate to subsurface mechanics. In this workflow, we apply DC removal and some filtering to improve the waveform quality. Then, we rotate waveforms into geographic coordinates using the information about receiver orientations. We identify and extract useful waveforms corresponding to microseismic activity in the event detection process. Then, we pick the onsets for P and S wave signals. Finally, we use model times from the calibrated model and picked arrival times to find hypocenter location. Depending on the receiver placement and monitoring well geometry, we may also need back azimuth calculations for the hypocenter location step. This concludes our explanation of the generalized processing workflow for obtaining hypocenter locations from monitoring waveform data. Now, the order and frequency of each step or element in the processing workflow can change depending on what the analyst thinks after reviewing the acquisition geometry and the quality of the recorded waveform. So my questions for you are, do you use similar processing workflow, and what has worked best in your experience and why? Please leave your response in the comment section, and I would love to chat more on this topic. Those who have not yet had a chance to work on microseismic processing and are interested to do similar research in your project or want to understand the processing workflow in more detail, Please also leave a comment and we can chat about the next steps. Thanks again for watching. Don't forget to subscribe to my channel and see you all in the next video.